This lesson is 5-2, buy or sell a car. Example 1. Jason wants to sell his Ford SUV. He compiles these prices from the internet for cars similar to his. What is the mean price for Jason to consider for his SUV? So we have to remember, how do you find the mean? You add all values and divide by the number of values. So we're going to add the 11,000 plus the 9,900 plus the 12,100 plus the 10,500 plus the 9,000. We're going to divide by 5. So go ahead and grab your calculator. I would definitely use a top-bottom fraction for this. So control division and type them in. So 11,000, 9,900, 12,100, 10,500, and 9,000 divided by 5. So the mean is $10,500. So when Jason sells his car, when he places his ad to sell his car, he should keep that in mind. So for the next question, there's a typo in it. So we're going to black out this value. It shouldn't be there. Hint, hint, that's the answer. So Maxine found the mean of 6 car prices to be $5,850. She is missing one of the prices. Find the missing price if these are the other prices. So what we have to do to find the mean, or to find the missing price when we have the mean, is we have to take the mean and multiply by the number of values there are. So it's kind of like this equation. So this equals the mean. So we have to multiply these two things, and it equals that all up. So it's the mean times the number of values equals add all values. Okay? So the mean is 5850. The number of values is 6, and we have to add these all up. So 7,500 plus 5,750 plus 4,900 plus 6,250 plus 4,200 plus the missing one. So 5850 times 6 is 35,100, and that equals 7,500 plus 5,750 plus 4,900 plus 6,250 plus 4,200, which is 28,600 plus my missing value. So subtract your 28,600 from the 35,100. So x equals 6,500. That's how you find your missing value, which was exactly the one we crossed off. So in a question on a quiz, a test, or practice, that value won't be there. Okay? So an outlier is a value that lies outside, is much smaller and much larger, most of the other values in the set. So do we have any outliers in this set? Not really. They're all pretty close. Okay, but if we had one for like 15,000, that would be an outlier. All right, and that would cause the mean to be off. It would cause it to either be way high if the outlier is way high, or if the outlier is really low, it'll pull the mean down. All right, so it's important that you look for those outliers and understand what's happening to the information you're given. All right, the next one. Dory is looking for a classic 1967 Firebird. She finds these prices on the internet. She computes the mean to be $28,171.43. The number doesn't seem to be a good representative of the data. What is the median of this data? And why is it not? Doesn't it seem to be a good representative? Well, this is the problem right here. This 77,000 is pulling the median or the mean up. It's making it too high because that's an outlier. So the median might be a better description. And remember, the median is the middle number. So when you line values up in order, it is the middle. So if we put these in order, we have 17,500. We have 18,000. We have 19,000. We have 21,200. We have 22,000. We have 22,500. And we have 77,000. And remember, 77,000, that's the outlier. So that's what's pulling the average or the mean up. So now the median, we're going to just match them up. So for the top one, there has to be a bottom one. For the next top one, there has to be a bottom one. For the next top one, there has to be a bottom one. So that makes this the middle. Okay, the median is the middle. So your median is 21,200. So the median is a better representative of this data when we have an outlier. So we talked about what the outlier does to the data, and you can see the higher the outlier, it makes the skew negative, which is where the tail is, and it's towards the negative side. And you can see that if the median or the outlier is low, it pulls the data to the left, which means the tail is to the right. And if there is no skew, it makes this really cool bell shape. Okay? So when the data is skewed, the mean and the median are not equal, which there's a better way to describe the data than the mean might be the median. All right? So for your check for understanding, go ahead and pause the video, find the mean, find the median, and then is the data skewed? Now, you should have found your answers, but I'm going to show you how to do it on the calculator. So if you go home and pick a new document, we want to list in a spreadsheet. We're going to go up to our box A is, and we're going to put X. If you hit Tab, it takes you to box B, call that Y. Now you could actually call those whatever you wanted to call them. You know, you could call them money, whatever. But we're just going to call them X and Y if we have two values. This time we only have one value, so we don't need that Y column. So what are our values? We have 1,200. We have 1,650. We have 1,500. 2,000. 2,000, 1,400, 1,850, and 1,600. Make sure you hit enter after that last value. So now, oh, I typed 2,000 in wrong. Make sure that your values are correct. And make sure you hit enter after that last value. So this was on page 6 in your notes if you need to go back, and these are one variable statistics. So now we're going to hit menu, statistics, stat calculations, and one variable stats. We only have one list, so click OK. What did we call our X list? We called it X, and click OK. And you can see your statistics here. Be careful because we're in the row 4. We want to go up to the top. So we can tell it says one variable statistics. X bar is our mean, which is 1,600. And then we can go down and we can find the median, which is also 1,600. So that's pretty cool. We don't have to do it longhand. So this one, your mean, which is your X bar, is 1,600. Your median is also 1,600. Therefore, it is not skewed, And the reason is because the mean equals the median. And this is the mean, remember. Okay? So when the mean equals the median, they are not skewed. All right? Okay, so now let's look at the next example. Prices found online for the same GPS navigation system are blah. Find the range of the GPS prices. So range is your max value minus your min value. Gives you your range. And if you recall seeing it when we used the calculator in the last example, there's our min value, there's our max value. So if we have to plug the data into the calculator to find the mean or the median or any other kind of statistics, then we can easily find the min and the max using the calculator also. In this question, since we only have to find the range, we'll just look. So the max value is 345. The min value is 199. So we're just going to subtract them. And we get 146. So the range of values is $146. That's pretty significant when you talk about the values only being 199. That range is pretty big. Okay? So that is not necessarily good. So now on the next page is all about the interquartile range and the quartiles that we can find on our calculator. So take a second, pause the video, and read through that. Highlight the important information. So, quartiles. Example 4. Find the quartiles of the tire pressure of the cars at an auto clinic. Tire pressure is measured in PSI, or pounds per square inch. So first look for the middle. So there are 9 values. So the middle is the 5th one. So this is the middle, the median, right? So now that means we have to find the middle of the lower part. So the middle of these 4 is going to be here. So there's 2 values. So how do you find the average of 2 things? You add them up and divide by 2. So we get 19. So this is quartile 1. This is quartile 2. And now we have to find the median of the top half. Well, here's the middle. So quartile 3 is 32. And quartile 4 is the max, which is 34. Again, we can use our calculator for this. So here's the really cool thing. If you pull up your calculator again, and you just go back to this data, these statistics will change as we change these numbers. So 15, 17, 21, 25, 31, 32, 32, 32, and 34. And you can see as I was typing, the values changed. So notice quartile 1, 19. The median, which is quartile 2, is 31. Quartile 3 is 32. And quartile 4, or known as the max, is 34. Okay, so that's a great way to check your work, or if you're just lazy, have the calculator do it for you. But you have to know how to plug it in the calculator. So now, example 5. What is the interquartile range? Interquartile range, or IQR, is the range of the quartiles. So range is max minus min. So what is the max quartile? Well, it's Q3 minus Q1. And that gives you your interquartile range. So if we're using example 4, quartile 3 is 32. Quartile 1 is 19. We subtract them. Therefore, we get an interquartile range of 13. So a lot of formulas here. Hopefully you remember them from previous math classes. All right, so our outlier, which we already says it lies outside the normal values. Our outlier boundaries are the interquartile range times 1.5, and that equals plus or minus quartile 1 or quartile 3. So what the heck does that mean? Well, let's go and find out. So find the outliers for these tire prices. So first we have to find quartile 1 and quartile 3 in order to find the interquartile range. So let's pull up our calculator again, and just to go through it again, I'm going to start new so we can practice. Let's get a list in a spreadsheet, go up to where A is and call that X, type in your values. And make sure you're practicing this because I cannot help you during a quiz or a test. You can use your notes, but that's it. Make sure you hit enter on that last value, look back through, make sure everything is okay. Alright, so now we're going to go menu, statistics, stat calculations, one variable, one list is okay, we called it X, okay. Alright, so we need our quartiles, so we're going to go down here. So Q1 is 98.5 and Q3 is 210. Alright, so holy cow, what's going on here? Alright, so now we are going to use our formula. So interquartile range, we must subtract them. So 210 minus 98.5 is 111.5. 111.5. And that is your interquartile range. So now I'm going to multiply that by 1.5. And I get 167.25. Now, what I have to do is add and subtract that from the quartiles. So I have to subtract that from quartile 1. So I have to do 98.5 minus 167.25. That gives me my lower boundary, which is negative 68.75. And then I have to take quartile 3, and I have to add it to quartile 3. And I end up with 377.25. So this is our range. Okay, this is our outlier boundary, or our outlier range, is from negative 68.75 to 377.25. So who does not lie within that range? Well, 545 is an outlier based on that formula. Okay, and that's the formula we're going to use. All right, so I hope that makes sense. So in the check for understanding, the store that charged $5.45 for a tire in example 6 had a sale and lowered its price to $3.99. Is the new price an upper outlier? And if we look at our math, $3.99 is still outside of that boundary or that range. So is the new price an upper outlier? Yes, it's still within the outlier range, or we could call it boundary. Alright, so now, oh my goodness, we have to go back. They want us to find the mode of the tire pressure in example 4. So the mode, what does mode mean? It's the value that appears, I guess, or we want to say occurs most often. So when I look at example 4, so here's example 4, which value occurs most often? And I hope you can see that it's 32. So the mode is 32. Make sure you know your statistics and how to use your calculator. Good luck!